Number one, the expression 1 over x cubed squared is equivalent to, well, there's a couple ways we could tackle this. I'm going to show this to you in two ways. One way would be to take this expression that you see right here in the middle and write it as a negative exponent, meaning x to the -3, but then squared. That's all I did was turn this into this. Then we see that we have a power to a power. What do we do with a power to a power? We multiply. And so we get x to the -6. Now that's one way. That's one way we could have arrived at that result. Another way would just be simply to take the expression that we have, 1 over x cubed squared, and we could begin by applying the square to both the top and the bottom. And if we do that, we get 1 squared over x to the 3rd squared. Well, 1 squared is 1, that's easy. X to the 3rd squared would be x to the 6. And if we write it as a negative exponent, we get the exact same result, x to the -6. So you have a couple ways that you could approach number one. Number two, we have an expression a to the 5/2 power, which is equivalent to which of the following as long as a is greater than 0. So as long as a is a positive number, basically. Okay. And the reason I say that is because 2 of your answers are square roots, and you can't take a negative root. So they're asking you to deal with only positive numbers. Okay. Well, I see that the problem says a to the 5/2. In the back of my mind, I should be looking to try and rewrite that. You have a rule that helps you out with that. X to the m over n is equal to what? N is the root, m is the power. So this is the same thing as the nth root of x to the m power. Now, what's the root? 2. What's the power? 5. So this is the same as the square root of a to the 5th power, which would just be written like this. You don't need to write the 2 in there. Which would be number 1. Now, number 3 looks hard, but if you really just rewrite everything as fractional exponents, then it becomes a little easier to manage, okay? So remember, if we have a root, the nth root of x to the m power becomes x to the m divided by n. So if I look at this big mess, I see 2 different roots and then something raised to a power. So there's really 3 things going on there. Let's deal with the outside root, this one right here. Well, since I don't see a symbol, that's automatically a square root. So what I can do is first begin by raising everything to the 4th power. So let's start there. The whole outside is raised to the 4th power. Then if I look at what's going on the inside, I'm raising something to the 1/2 power. So I'm going to make parentheses to the 1/2 power. And then inside those parentheses is, well, the inside function, which is this one right here, the cube root of 2. Okay, recall that the cube root of 2, that's cube root of 2 to the 1 power. So this is the root. Okay, but I say root, this is the n is the root, m is the power. So this is the same thing as 2 to the 1/3 power. So we can rewrite it kind of like that. So I'm going to write 2/3 or 2 to the 1/3 power inside. And so now to just kind of clean this up, all we have to do is go 2, that's the base, to the 1/3 times 1/2 times 4. Since we're raising a power to a power to a power, we simply multiply our exponents. To multiply exponents is pretty easy. We just multiply straight across. And this is 2 to the 1 times 1 times 4, or 4 over 3 times 2 times 1, or 6. Now that can be reduced to lower terms, and that's 2 to the 2 goes in each one, 2 to the 2/3. Now recall, m is the power, which is the numerator, n is the root, which is the denominator. So you should be able to rewrite this as the cube root of 2 to the second power, which is the cube root of 2 squared, or 4. Okay, so that was kind of a tough one, but you can arrive at the solution by really breaking everything down into their fractional exponents. Number 4, it says the expression x to the third raised to the negative second power over x squared times x to the fifth can be rewritten as 1 over x to the k, where k is some integer. Remember, an integer is a whole number or 0, right? It's a counting number, a negative counting number, or 0. Okay, so which of the following represents k? So we're looking to find out what that integer is, right? What's the exponent? 16, negative 16, 13, 6, or 4. So let's break this down. Okay, I'm going to start by rewriting this. So x to the third to the negative half power over x squared times x to the fifth. Okay, and we're going to apply our rules for exponents differently. On the top, I see a power to a power, so I'm going to multiply those. So this is x to the 3 times negative 2. On the bottom, I see I'm multiplying same base, so I'm going to add those exponents, x to the 2 plus 5. Well, this becomes x to the negative 6 on top over x to the 7 on bottom. Now, when I'm dividing same base, I subtract the exponent. So this becomes x to the, and you always start with the top exponent, always. So it's x to the negative 6 minus the 7 on the bottom, which would be x to the negative 13. Now it asked us to write it in this form here. Well, that would be the same as 1 over x to the positive 13, which means 13 must be your k. 13 is my exponent, which is my k. Okay, flip the page. Well, in number 5, we have an expression 2 to the x power over 16 can be equivalently written as, well, here's the thing. I should be trying to write this fraction. Let's rewrite this fraction. Having the same base. In other words, I already see a base of 2, so let's rewrite 16 so it also has a base of 2. That way we could apply some of our properties here. So this is 2 to the x power over 16. I'm going to rewrite 16 as 2 to the something power. Now, what 2 to the what power is 16? Yeah, it's 4. 2 to the 4th power is 16. So in other words, I could rewrite this as 2 to the x power over 2 to the 4th power, because 2 to the 4th power is 16. Now, what am I looking at here? Dividing, same base. That means 2 to the, what do I do with my exponents? I subtract them, x minus 4. I do believe that is one of our results. Yeah, that's number 1. Okay. Now, in number 6, the radical expression, the cube root of 135 x to the 4th y to the 8th can be simplified too. Now, here's what I should be thinking in the back of my mind. I need to break this up into the perfect cubes. Okay, so the first thing I need to do is take care of the number. Let me kind of review my list of perfect cubes. What are my perfect cubes? The cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. And the cube root of 125 is 5. So what you're doing is you're looking to take that 135, right, and see if it's divisible by either 8, 27, 64, or 125. I think you can realize that 125 is not going to be the result. That's just simply too close to 135. But take 135 and see if it breaks into anything. It does go into 27 5 times. So here's what we will do. We're going to take that cube root and we're going to break it up the following way. We're going to break it up into 27 times 5. 27 times 5 is 135. The black represents what I can take the cube root of, like we worked on Friday. The blue represents what I cannot take the cube root of. Now, in this one here, I have x to the 4th power. Well, I can only take the cube root of multiples of 3. 4 is not a multiple of 3. So the largest exponent that I can take the cube root of is x to the 3rd power. So I'm going to take that x to the 4th, which is x times x times x times x, and I'm going to take 3 of those x's, put them here. I'm going to put that last x over here. So x to the 4th power has been split up. Then I'm going to take my y to the 8th power. Again, I can only take the cube root of multiples of 3. What are your multiples of 3? 3, 6, 9, so forth. So I can only take the highest exponent I can take the cube root of would be the cube root of 6. So I'm going to take the cube root of y to the 6th power. But you'll notice I've got 8 total, so I need 2 more left. I'm going to put those 2 over here. So I'm splitting it up. The first step in doing this is just split it up. Split up the number into its factors, 1 being the largest perfect cube. 2, split up your variables into what you can take the cube root of and what you cannot. Again, what you can take the cube root of has to be a multiple of that root. If this were a square root, we'd be looking at multiples of 2. If it's a 4th root, you're looking at multiples of 4. This is a cube root, so we're looking at multiples of 3. Now we take the cube root of anything we can. So the first part, what's the cube root of 27? We start there. Well, that's 3. What's the cube root of x to the 1? X to the 3rd power? It's x to the 1. We go x to the 3 divided by 3. We divide the power by the root. The exponent by the root. So x to the 1, and then we take the cube root of the last one, which is y to the 2nd power. 6 divided by 3 is 2. And then everything in blue is I can't take the cube root of it, so it stays under the radical. Make sure we write a cube here, 5x y squared, and I don't need the 1 right there. And that would be, which one? Number 4? Number 7, the expression x to the negative 1/4 is the same as, well, x to the negative 1/4 is the same as 1 over x to the positive 1/4. So we can start there. Then if we recall, x to the m over n is equal to the nth root of x to the m power. So we could rewrite this as 1 over the 4th root of x to the 1st power. which I don't need to write the first power. It's just 1 over the 4th root of x, which would be number 3. Number 8, the expression, the square root of x to the 5th power divided by the 4th root of x to the 7th power can be rewritten as, again, this looks a lot more complicated than it is. Your job is to rewrite everything as fractional exponents first. So again, the nth root of x to the m power is x to the power divided by root. So I'm going to take this down. This is the square root of x to the 1st power to the 5th. You guys see what I did there? I just put a little 2 in there and I put a little 1 to remind me what m is and what n is. Helps me convert it better. Divided by, it's already written there, the 4th root of x to the 7th power. Okay, so the first one, start with the first one, take care of that. That's the same as x to the 1/2 power raised to the 5th power all over x to the 7/4 power. Multiply those exponents. We were talking about a power to a power, so we multiply exponents. And that is x to the 5/2 power. 5 times 1 over 2 times 1. Divided by x to the 7/4 power. Since I see same base right here, I'm going to subtract my exponents. So this becomes x to the 5/2 minus 7/4. Now, you guys remember, in order to subtract exponents, I need a common denominator. So my common denominator would be 4. So I'm going to multiply this top and bottom by 2 over 2 so I can make that 4. Let's rewrite this as x is equal to 10/4 minus 7/4, which is x to the, just subtract the top, 3/4. Now, looking at your answers, it looks like they all want to be written in radical form. So again, this is the power, this is the root, this is the 4th root of x to the 3rd power. Which is number 1. All right, second page. So which of the following is a simplified version of that? Wow, that's a lot going on there. So first things first, this big thing right here, that's a square root. So what I'm going to do is I'm going to kind of rewrite everything. First, I have the big 6th power, everything to the 6th power, right? Then I've got this big, huge square root, which would be, again, everything to the 1/2 power. Because remember, a square root is something raised to the 1/2 power. So all I did was turn this into this. Then we've got what's underneath, which would be 1 over, and I should try and rewrite that as well. It's x to the 1/3 power. Remember, the cube root of x to the 1st power is x to the 1/3 power. Okay, now what do we do with this? Then I'm going to take this right here. I'm going to apply the 1/2 power to the 1 and the 3. And I'm going to hold that 6. I'm going to do this in steps. If I try to do too much at once, it's going to feel overwhelming. So do it in steps. Keep the 6 outside. And this is 1 to the 1/2 power over x to the 1/3 to the 1/2 power. So all I did was split it up. So keeping the 6th power, what is 1 to the 1/2 power? Guys, 1 to the 1/2 power is the same as the square root of 1. That's just 1. If I'm raising a power to a power here, 1/3 to the 1/2 power, I multiply those exponents. So that would be 1 divided by 6, right? 1 times 1 over 3 times 2. So 1 to the x to the 1/6 power raised to the 6th power. Now, what am I going to do with this? I'm going to do the exact same strategy, but this time I'm going to raise each part of this fraction to the 6th power. So rewrite it first, and it's 1 to the 6th power over x to the 1/6 raised to the 6th power. Well, 1 of the 6 powers 1. That's easy. Again, what do I do with this? Multiply. So that's x to the 1/6 times 6 over 1, which cancels. That would be the same as 1 over x to the 1 power, which is 1 over x. Now, I don't see that. Oh, yes, I do see that. That would be the first option. I was going to say, if you didn't see that as an option, then you would rewrite this as x to the -1 and look for that option. Okay, a lot going on in number 9. Okay, in expression, the cube root of b raised to the 5th power times 1 over b squared can be written as b to the power of a in simplest form. Determine the value of a, show you how you arrived at the answer. Again, put everything in fractional exponents so that you can use your property of exponents. So the nth root of x to the m power is x to the m divided by n. So this is n, this is the power, m. So I can rewrite this as b to the 5/3 power times 1 over b squared, which over 1, this is the same thing as b to the 5/3 power over b squared. So I can kind of start there. Since I see same base, I'm going to go ahead and subtract my exponents. So this would be b to the 5/3 minus 2. Right? Same base, dividing same base, we subtract our exponents. But I need a common denominator. The common denominator would be 3. So I'm going to multiply this times 2 over 2 to make it 3. Which part? Right. I mean, well, I want a common denominator of 3 here. Did I multiply by 2? Okay. Yes. Thank you. Yes. 3 over 3. Thank you. So yeah, that's x to the 5/3 minus 6/3, which would be b to the 1/3, -1/3 power, because 5 minus 6 is -1. Okay, and so then looking at that right here, if this is our simplest form, b to the a power, that means that a is -1/3. Okay, Jalen and his brother Tyler are both in integrated math 2 and are debating a question about roots. Jalen believes that taking the square root of a number and then the cube root will result in the same as taking the 6th root. Tyler disagrees and believes the combination of the two roots will result in a 5th root. Who is correct? Okay, so the first brother thinks that taking the square root of a number and then the cube root. So we're gonna let the number be x. Okay, so we're gonna take the square root of x, right? And then the cube root. So there's two layers going on here. So what do we have here? The inner one is x to the 1/2 power raised to the 1/3 power. What do we do with a power to a power? We multiply. It is 1 to x to the 1/6 power. M is the 1, n is the root. This is the 6th root of that number. Right? Jalen is correct. Okay, and lastly, write the 4th root of 80 times x to the 9th power times y to the 16th power in simplest radical form. Now, to do 4th roots, make sure you have your list of perfect 4th roots. Well, the 4th root of 16, for instance, is 2. The 4th root of 81, for instance, is 3. And that's really the only two you have to know. And since you have your notes in front of you and you're clearly annotating your page along with me, you'll have that. Now, which of those numbers? Obviously, it's not going to be 81 because 81 is over 80, right? So it's going to be 16. So using your calculator, take 80 divided by 16 and see how we're going to split up that 4th root. 5, right? So we're going to put 16 over here. And then in blue, I'm going to write 5 over here because 5 times 16 would be the 80 that we're splitting up. Now we're going to take a look at the x's. What's the largest exponent I can take the 4th root of? Well, the answer to that question is, what are the multiples of 4? 4, 8, 12, 16, and so on, right? Is 9 a multiple of 4? No. What's the highest multiple of 4? 8. So I'm going to take 8 of those x's, and I'm going to put the last one over here. X to the 8 times x to the 1 is x to the 9. Now, y to the 16th, I can take the 4th root of because 4 is a multiple of 16. So that one works out fine. Last step, take the 4th root of the black part, which would be the 4th root of 16, which is 2. The 4th root of x to the 8, which is x squared. 8 divided by 4 is 2. And the the 4th root of y to the 16th, which is y to the 4th power. 16 divided by 4 is 4. All times the 4th root of what's left over, 5x.